soft and squishy robots can teach engineering in the classroom? Yep, next on the K-12 Engineering Education Podcast. I'm Pius Wong in Austin, Texas. My guest is Dr. Holly Golecki, an engineering professor at the University of Illinois at Urbana-Champaign. Dr. Golecki's research team recently published an article in the magazine The Science Teacher titled Revolutionizing Robotics, Broadening the Definition of Engineering by Engaging Students in Soft Robotics. Besides discussing their new soft robots curriculum, Dr. Golecki and I spoke about becoming a materials engineer, being a high school teacher, motors made out of candy, and more. Dr. Holly Golecki, really appreciate you joining the K-12 Engineering Education Podcast. I would love to hear more about just you and how you got into engineering in the first place.
Yeah, great. Thanks so much for having me. I'm really thrilled to have this chat today. I guess for how I got into engineering, like many people, I was in high school and decent at math and science. And so I was encouraged by, my teachers and my family to study engineering. I didn't really know what that meant at the time. So I enrolled actually as a civil engineer because I kind of looked around and thought, okay, buildings and bridges. That's what a civil engineer does. I'll do that. And then it wasn't until I got to Drexel University, where I did my undergrad, that I learned, all about the different types of engineers that exist and that work in the world. And I got really excited about material science and engineering. It was kind of a small department at Drexel, but they had a lot of really interesting programs and a lot of really interesting ways to engage students in thinking about, okay, how can I use engineering in a material science way? And so I studied material science as an undergraduate and just got really excited about polymers and all things soft and squishy.
You basically were interested in the soft and squishy parts of engineering for a long time then?
Yeah, because in material science, you do learn about metals, ceramics, and polymers, but it was really polymers that got me interested. And then when I finished my undergrad, I thought, okay, what do I want to do next? And I was really interested to apply materials inside the body. So I got my Ph.D. in bioengineering with the focus of engineering protein-based materials for different applications in the body.
That sounds really intense, to be honest. And I do understand from my bioengineering background, there's so much interdisciplinary work that I'm sure you did as you were studying all this stuff. Was there a particular part of polymers or this bioengineering field that you studied that you really enjoyed?
Yeah, I really loved, to get pretty technical, like mechanics of materials, looking at the properties of these protein-based materials and the chemistry and how kind of the chemistry informs the mechanical properties. I thought that was always really interesting. And then, once then you enter the body, there's just so much going on that we don't have a ton of control over or a full understanding of. And so it just was a really interesting place to apply materials, that kind of all of it coming together. And like you say, a very multidisciplinary field, an area that I've always worked in. And I really love that about engineering.
Yeah, and speaking of interdisciplinary fields, even beyond engineering and science, you're also really interested in education too. When did that interest spark?
Yeah, so I would say, growing up, I didn't know very many engineers. I really only knew one engineer before I decided to go study engineering. And I did always want to be a teacher. I had a lot of really amazing teachers growing up, all through my kind of K-12 career. And that's what I thought I wanted to do. And even through graduate school, there was always that tug of, should I go and become a K-12 educator? And I had engaged in a lot of outreach, I would say, in undergraduate and in my grad degree. And I just really, really enjoyed it. And I had a really unique opportunity. I met someone one day, and I was telling them, I really want to be a high school teacher, and I don't know, is that okay? I'm studying engineering. And they said, oh, there's this website you should check. There's, job postings and, maybe there'll be something interesting. And so I went and looked, and there happened to be in the town that I was living, They were looking for someone to create a 2-week engineering course, just like a short course to be taught on Saturday mornings for some of their students. And so it was perfect. It was something I could do on the weekends, and I loved it. It was so much fun. I taught all different types of engineering. We did different topics every week. We were building stuff. It was just really, really fun. And it was cool to, it was supported by the community. Community members were kind of funding the program. And so it felt like this was something that, the school really wanted to happen. And the students were very engaged. And so that really then cemented for me this idea that, yeah, I do want to go into education. And
Wow.
so, yeah, so that's what I did. I was a high school teacher for 5 years.
No kidding. I did not know that. So
Yeah.
this is coming out of Drexel. You started teaching like right away?
No, so this was coming out of Harvard after
Oh, wow.
graduate school.
Oh my goodness. So you had already done a lot of that hard research in materials engineering, and then you're like, okay, now we're going to teach some of that to kids, or
Yeah, yeah.
no, that's
Yeah,
really cool.
exactly. Yeah, so I taught it's an all boys private school outside of Philadelphia called the Haverford School. And I taught science there. So I taught engineering courses, physics, and biology while I was there.
All of which, of course, is very relevant to your studies. So I imagine that your school really appreciated your knowledge base there.
Yeah, it was fun. I always tried to, sneak in a little bit about, kind of the research that was going on, so that the students could see, like, hey, how can this apply
Yeah.
in the future?
Because you didn't study officially to be a teacher, I'm curious, did you have to learn a lot on the job of how to be an effective educator?
Oh, yes, absolutely. So, yeah, in Pennsylvania, I couldn't teach at a public school because you have to have education courses.
Right.
So that's why I ended up teaching at a private school. But yes, I had to learn a lot on the job, all the classroom management and, teaching to different learning styles. But the school and my colleagues were all very supportive of new teachers coming in. And so, yeah, it was a lot of learning on the job for sure.
Okay. Well, I'm sure that you applied it in a lot of different ways. So you eventually made your way to UIUC.
Yeah, so I had been teaching for about 5 years, and it was I had gotten into soft robotics at the school. I was running a mini research group at this high school for students that were interested. And, I guess I would say at the end of my graduate degree, I didn't see myself continuing the purely technical research, but I knew I wanted to be in education. So I thought K-12 was where I would do that. But once I got into soft robotics and saw the potential that there is for engaging a diversity of students in robotics and kind of learning about the robotics field, I also learned about the field of engineering education research. And so
Mhm.
then at that point, it made a lot of sense for me to move to the University of Illinois and, teach in the bioengineering department, but also to do research in engineering education. So that's kind of how I put all these things together. It reinvigorated my interest in academic research. I had this new kind of problem that I wanted to address, to not only address but
Mhm.
to understand as well.
That's fantastic. I do relate to that idea of trying to combine engineering and education, and sometimes you have to just take an opportunity when it arises. So I'm really happy to hear that.
Yeah.
And just as an aside, I mean, I understand that UIUC's bioengineering program is relatively new, I think, compared to some other universities. And I know you didn't join like right at the start, but I'm just curious, like, how's UIUC's bioengineering program so far? I assume you went there because it had a lot of what you were looking for, that they value education as well, not just
Oh, yeah.
pure research.
Yeah, so I'm a teaching assistant professor in the bioengineering department, and so there I have a number of colleagues who are teaching faculty, and
Mhm.
there's a ton of support for this career path at the University of Illinois. They're very invested in education, so the building that our department is housed in has tons of active learning classrooms, and so there's a big emphasis on undergraduate education and making it a meaningful and authentic experience. So I definitely really liked that. And also, a number of my colleagues engage in engineering education research. So there's colleagues that I can work with in this area, and it's valued here. And so, yeah, it just had a lot of the things going for it that I was looking for. It's an amazing university and an amazing engineering college.
Fantastic, because people do have that reputation, or they know the reputation, I think, of the University of Illinois for their engineering, but it's great to hear that they're also kind of modernizing education in STEM as well.
Yeah, for sure.
Can you tell me a little bit then about some of the research you do at U of I?
Yeah.
I know you do just straight biomechanics research, bioengineering research, but you also do the engineering education research. What would be like the quick summary, if you could, of
Yeah.
the various things you do?
Yeah. So, when I talk to people about what I do, if I were to summarize it in like one phrase or sentence, I would say that we work at the interface of materials and humans. So, the biological and the abiotic or non biological materials. And so that can mean implantable devices to be, implanted inside humans. That can be wearable technologies, but that can also be educational materials that students interact with. And what we do is we try to build new materials and devices, and then we try to see how they might interact with a human, whether it's inside the human or the human is using it in some way, holding it in their hands or learning from it.
Yeah, I saw some of the examples of the stuff that you're doing. At least earlier in your career, I saw a lot of stuff about processes for creating nanomaterials. Are you still doing stuff like that too?
Yeah, so we have an active collaboration with some folks at Sandia National Labs. We just had a paper out, so we have a variety of students working in my group. A lot of them are undergraduates because, my passion for education also, is alive and well here at the University of Illinois. And I love to give undergraduate students, new opportunities to do research and to really
Mm.
apply what they're doing in the classroom. So I definitely have a big emphasis in engaging undergraduates in research. And so over the past few years, we've gotten to send students from U of I to Sandia National Labs for the summer to do a collaborative research project. And our latest paper that came out a few months ago is about hybrid microgrippers. So we're essentially building tiny, soft actuators on the end of optical fibers with the idea that we could maybe, send them navigate through the body to detect, different disease states, and then maybe take a biopsy or deliver a drug, depending on the application.
That's
So
really cool.
yeah, so the soft part is a gel that's we have some that are sensitive to light, sensitive to temperature, and sensitive to pH. And so, cancer has a lower pH than healthy tissue. And so the idea is in one specific example of what it could do is that, you could navigate this very small fiber that's, a little bit bigger than a strand of hair into the body. And if it detected a cancer cell, it could do a biopsy for us. And so, we think about minimally invasive surgeries and how quickly we can have some procedures these days. You can have surgery and go home the same day. And
Mm.
so thinking to the future, medical devices, surgical tools are going to get smaller and smaller and smaller so that we can detect diseases earlier and earlier to, save more people's lives.
That's pretty awesome. I think you did a good sell of this kind of technology. These microscopic hands and precise actuators into the body can do a lot of good stuff. And then maybe on the other side of what you do, you were also talking about that engineering education research, even involving new materials. Is there an example of that that might demonstrate that you do?
Yeah. So, one project that we've done that always gets a lot of excitement and is just really cool is when I initially kind of got working with young students, high school students in this field of soft robotics, we were thinking there was a competition. So the Soft Robotics Toolkit is an online resource. I forget the actual title. Let me look up my contributor, I think is my title. Sorry, let me look this up really quick.
Yeah, no worries.
I forget what I'm listed as.
Clearly,
Um,
the title is probably not as important as the contribution that you have,
yeah,
but we'll
yeah.
look it up.
On the development team. Okay. So that's what
Got
I'm
it.
going to say. Okay. So when I first started working in this field, do you want me to just tell the story about kind of how I got
Yeah,
working on this? So
yeah,
I was
sure.
teaching, yeah, I was teaching high school, teaching engineering, and like I said, physics and biology. And there was a need for someone to kind of help run the robotics program at this school, which was a very robust program. They competed at a very high level in the VEX robotics platform. And it was very popular. There were many, many students at the school involved. And they that year in particular, they got third. They placed third in the world. And so, I started to think like, okay, we've achieved all this success. Like, what's next? What else can we do? We have all of these talented students who are hungry for opportunities to apply, what they know and learn more about robotics. And so, a friend turned me on to the Soft Robotics Toolkit.
Hmm.
So they were hosting a competition at the time. It's like an open source platform with design guides, fabrication guides, and kind of how-to videos on how to get started in this field. And the objective of the competition was to advance the field of soft robotics. So I got together with a group of students who, were kind of interested, to try this new thing that they knew nothing about. But I found a few willing participants. There were probably about 7 or 8 students. And so we started to brainstorm like, okay, how can we advance this field? Being a bioengineer, I thought, okay, how can we better build these soft materials, soft actuators for use inside the body? They're typically made out of a polymer called silicone, which is inert, but not great for long-term implantation in the body.
Mm-hmm.
And so we started to think about, okay, could we build these actuators out of the proteins in our own body? But we were at a high school, right? So we're sort of limited in the equipment that we had. So we started to think about, okay, maybe gelatin would be a good candidate material. It's a derivative of collagen, which is, a primary protein in our bodies. And so let's get some Jell-O and start making gelatin actuators. And then, it kind of morphed into, edible actuators. Could your food crawl into your mouth if you're able to make a robot out of entirely edible materials? And then long term, could you put some of your proteins away early in life, and can they be preserved for you so that if you need a medical device down the line, can we build those medical devices out of, our own proteins in our body? It's kind of like very long, far-reaching ideas about how this could be used. So yeah, we just started making gelatin, playing around with the properties. Jell-O wasn't really right for what we wanted. It was tearing, has like a very low tensile strength. And so we ended up melting gummy bears because they're, very stretchy. And so the actuators that we were aiming to make were pneumatic. So we were going to basically blow them up like a balloon. And so, so we ended up melting gummy bears and molding them and then making actuator fingers that could bend and curl when we inflate them with air.
That's interesting. Oh my
Yeah.
goodness. And then when they go bad, you can eat them.
Yeah,
Okay.
absolutely.
Yeah, I had noticed that you were involved in at least one paper. You can correct me if I'm wrong about candy actuators. I don't know if it's about what you were just talking about, but that was something that I never knew about back in the day when I was trying to study bioengineering. Is that something that a lot of folks are thinking about? Maybe not candy actuators, but edible actuators, these things that literally were not on my mind 10 years ago.
Yeah. So, I mean, what was really interesting, so the paper that you're mentioning was actually, it was me co-authored with the high school students that I had worked with on that program. They were, very engaged students, and we had an opportunity to bring them to a conference because I had been a Ph.D. engineer, so I knew kind of about going to conferences, and so I thought, okay, maybe we can go to a conference and they can talk about this, and it was a really great opportunity for them. So they then afterwards were inspired to kind of help me write a paper about it. So yeah, it was actually with the high school students. But while we were working on it, someone came out with a paper from a formal research group that was looking at gelatin-based actuators. And so it was really exciting. I guess getting scooped in a scientific sense isn't always, fun. but for me, it was really great. It was like, we're on the right path. I'm working here with high school students, and these are things that, academic researchers are also thinking about. So yeah, since then, there's been a lot of work that's come out about edible actuators, sensors. I think there was an edible battery paper that came out a few months ago I saw. So I definitely keep my eye when I see anything edible.
Yeah. No, that's really cool. It's like one category in the giant Venn diagram of soft robotics, maybe,
Yeah,
where I
for
see that
sure.
that really applies. And just to jump up one level, you work with college students too, clearly, with research and with teaching. And one thing I did want to ask you about also was I saw that you teach a range of classes to college students, both in the past and now at U of I. For example, I know that you teach Introduction to Bioengineering, kind of like the first time undergrads are exposed to what bioengineering is, you teach that.
Yeah,
But you
exactly.
also teach senior design,
Yes,
which
I
is
do.
oftentimes the capstone course. And so I'm very interested. What are your thoughts on seeing students kind of at the beginning and at the end of their bioengineering studies? Do you notice growth in them
Oh,
or
yeah.
okay.
Yeah, absolutely. I just actually had my first class. So I've been here for this is my fifth year, and so I had just had my first class of students who had in BioE 100, which is our introductory course, and then had them in the capstone course as students. And yes, it's amazing. I mean, Illinois has a ton of resources for entrepreneurship. So some of them have started
Mm,
companies since their freshman year, or since their first year. They've done internships and they've gotten engaged in so many different projects and programs outside of the classroom that they are totally different people when they come to senior design. It's awesome to see. It's really, really great. A lot of students in their first year, they were like me. They didn't really know what they were getting into. They're
mhm.
trying to figure everything out, but they come to senior year very confident, and excited to apply everything that they've learned on this capstone project, which we get projects from all over, from hospitals, from industry, from kind of academic research spaces. And so students really get to apply what they know in the areas that they're most interested in.
I'm just thinking back of my own experience in senior design. I just remember the senior design course. I could have done a lot better, or I don't know. I just felt like the educational environment could have been a lot better at the time. And I'm glad that it sounds like that design thinking is really being embraced at Illinois and other places. And it's cool that you can see the effects of what you teach. So that's really great.
Yeah, yeah. We've been pretty intentional about trying to build design throughout the curriculum. So it's not the first time they're seeing it, but it is the first time that they're really responsible for a project. So your sentiment about, wishing it maybe went differently, it is we try to tell students it is the first time you're getting the opportunity to kind of run a
Right.
project all on your own. And so it's a great learning experience for a lot of students.
And so that brings me to the topic of that new paper that you have out for teachers in K 12,
Yeah.
Revolutionizing Robotics. I wanted to ask, is that kind of an effort coming out of your undergrad research as well? Like you have a team of folks who helped you put out this paper. Are they your students?
Yeah, so my co-authors on this work are Thomas Tran and Elizabeth McNeila. They led the project. They are undergraduates from University of Illinois in the bioengineering department who just graduated.
Hmm.
Jason Robinson is another undergrad who is just starting his junior year, who assisted on the project. I have a colleague from University of Michigan, Karen Jensen, who helps me on kind of the instrument design and designing the kind of education research aspect. And then Jill McLean is a teacher from Centennial High School in Champaign, Illinois. And she really
Very
helped
cool.
us a lot with the curriculum and,
Yeah.
making sure it's appropriate. Yeah, it was an awesome team to work with.
Yeah. Tell me about what you all did. What was the goal of this project?
Yeah, so this was an NSF funded project that kind of came out of my work at the high school. So when I was there, like I said, there were a lot of students who were really interested in robotics. And then when I started the soft robotics program, I didn't have all of the same students there. The students who came to soft robotics, maybe they were interested in art, maybe they were interested in chemistry and
Hmm.
design, and they definitely approached it from a different angle. And so, I was working at an all boys school, but I was going to robotics competitions and seeing the kind of low rate of participation of girls and women in the robotics space. And so I got thinking, I'm drawing a different type of student here to this soft robotics program. It has healthcare applications. And then, I went to University of Illinois, and we have 50%, over 50% women identifying students in our undergraduate program.
Hmm.
And so I thought, okay, maybe all of these things are kind of can come together in this like multidisciplinary sense, like we talked about earlier, where maybe soft robotics has the kind of traditional robotics elements, mechanical and electrical engineering are definitely important there, but it also includes these kind of healthcare applications which align with agency beliefs. This idea that I want to use engineering to help my community. And, maybe soft robotics is a way to diversify, at least at the start from a gender perspective, who participates in robotics. So hoping that, if I can use robotics in the body, maybe that's going to attract more girls to come and participate. So Karen Jensen and I, Dr. Karen Jensen and I from University of Michigan applied for this NSF grant and were awarded it. So we were really excited to be able to explore this idea. So that's exactly what we were looking at. So we worked at a school here in Illinois, and we designed a curriculum based in soft robotics, and leveraging a lot of what exists on the soft robotics toolkit, what's been published, and then our own efforts in this space to build out a week-long curriculum for students. And then we actually tried to measure changes in their thinking about engineering and who can do engineering, and if it's of interest to them.
In your paper, the results are positive. And you tried it. What was it, with 80 students in a physics class for
Yeah.
juniors, something like that? And so, yeah, I mean, it is kind of specific, but at the same time, it seems like the results you have show a lot of promise that you could probably extend this out to more folks. Maybe before I get into the results, actually, do you want to talk about? Can you describe briefly, or not briefly, describe in as much detail as you want, what is the week-long curriculum? I think a lot of teachers might be interested in those details.
Yeah, so the goal of the Science Teacher article was to put the curriculum out to the community so that teachers can use it if they're interested to. We tried it in a few different ways. So you can run it as a 1-week curriculum. You can also do it, 2 days in a week, take a break, 2 days in a following week, depending on testing that's going on at the school or different activities that have to get completed. But it was a, 5-day curriculum aimed at, fitting into a 40-minute period, so that things could be cleaned up and the next class can come in, and try to really make it teacher centered in that it's manageable and reasonable to implement was a big part of our goal. Having been a high school teacher, I understand that, yeah, you can have really awesome ideas, but if it's overly burdensome to execute, there's so
Right.
many things that need to get done that people are going to shy away from
Right.
engaging in it. So
Yeah. Nothing's
um,
catching fire, I
right.
saw in your curriculum.
Yeah, no. But the students, I would say, Elizabeth and Thomas, they did a lot of prep work to make sure that it was went really smoothly. But so the students, they build 3 different actuators. And so the first being a tendon-based actuator. So it's, a pretty easy way to start. We make a silicone finger. It has a rigid backbone. You can think of it like a bone, to kind of give the finger some structure, and then a softer material on the top. And it has threads through it. So we can kind of tie it to previous biology classes, which these students have had, and talk a little bit about the physics of how it's working. And then we go ahead and build the pneumatic actuator. So this is, you could think about like a balloon animal balloon.
Hmm.
And if you were to put a piece of tape on, a tape strip down the balloon and blow it up, it might curl towards that tape because the tape is stiff and the balloon can't expand. So, on a podcast, that's my easiest way to
Sure.
describe it so people can maybe visualize it. But essentially, we make a silicone finger that has holes through the center that we can inflate, and then we put a piece of fabric on the top, and that keeps it stiff on one side. So then it will curl just like a finger bending. And we can make that out of silicone, or we can make that out of gelatin and gummy bears. So you can kind of
Hmm.
try different materials. And then lastly, we make what's called a McKibben's actuator, which was first developed, I think, in the 1950s. It's a braided cable with a balloon inside. And then when you inflate the balloon, the cable shortens. And so it's a shortening actuator. So it works a lot like the muscles inside our body. And then so they build those 3 foundational components. We teach them a lot about, engineering in general. This maybe is their first exposure to engineering, and we have all of the curriculum available in this paper that we've been talking about, to help teachers kind of guide them through that discussion. There's so many awesome videos. When I was a teacher, I didn't necessarily have access to academic research papers, right?
Hmm.
But a lot of universities, when they have a big paper coming out, they'll make a YouTube video about that work, something short for, the public. And so that's an awesome way to get students to be able to see what we're talking about and watch the researchers talk about it a bit. So I've leveraged that quite a bit in this curriculum. And yeah, so then the students can think about, okay, if I put the muscle with the finger, can I start to actually build like a hand assembly? And then we get them attaching multiple fingers together to see what they can and cannot pick up.
Hmm.
And then engage them in a little bit of design work at the end. So just kind of getting into like the very beginnings of a design thinking curriculum where, we ask them, what could be better, what could be changed, what does this remind you of? And yeah, it's been really fun. So that's kind of a summary of the curriculum that we have.
Yeah, thanks. I mean, I read that you have group work built in. It's very project based,
Yeah,
following those
exactly.
kinds of pedagogies. Are there any specific types of classrooms you think it would work in? Would it work best in this junior level physics class, or do you feel like you can apply this to other folks?
Yeah, so we've been talking with teachers that we worked with, and Jill McLean, who's on our advisory board and helps us a lot. We are thinking about, could this go into a biology classroom? One that some of the teachers were saying, could we have this even earlier? By the time students are juniors, they have, even though they're still young, they have some ideas formed about what they want to study or what they want to do when they finish high school. And so,
Yeah.
we're thinking about, if we introduce it even earlier, can we maybe shift some of those
Hmm.
thoughts and maybe give them some additional ideas about potential career paths? If they really like it and we were able to build it over multiple years, could we change some of their minds about whether or not engineering is for them?
Yeah, that's interesting you raise that up because I've seen similar research about like you just have to get at folks earlier, especially if you're talking about, for example, gender disparities or even racial disparities. Yeah, the earlier that you can interest folks in soft robotics or engineering in general, it sounds like that would be a good thing to do.
Yeah, yeah. So we've done this project with students as young as first grade.
Hmm.
So we had a group of Girl Scouts who were earning a robotics badge. So they were Daisy Girl Scouts, so they're in first grade. And yeah, we had them building, a more condensed version of this that was maybe more cooking show style, where we had some things prepared for them ahead of time, but they were able to mix the silicone and pour it in the molds and then come back and demold it. So yeah, we're definitely thinking about, how early can we start introducing these ideas? How can we build curricula that builds on itself so that students can kind of deepen their understanding over the years and apply different types of science and math? And then thinking about community colleges, many of the students that we worked with were in dual enrollment programs. And so could we potentially think about, an engineering dual enrollment program so that students who are interested could start going to the local community college and taking, college courses in engineering or pre-engineering?
That's really cool. So just to reiterate what you were saying, it really does sound like you had two main goals. The first one, of course, is to expand knowledge in engineering, but you're really not shying away from the second big goal of just broadening access or broadening interest in engineering in general.
Yeah, exactly.
Okay. And you talked about how you might change or adjust or differentiate this curriculum for different populations. Are there any special considerations you think teachers should make if they're investigating creating these soft robots or soft actuators, like accessibility issues or cost, or I don't know, anything that you think they should be aware of?
Yeah, so one of the other reasons why I really like soft robotics is the low cost associated with the program. So on the soft robotics toolkit, you can actually make the molds for these out of cardboard. So it can be very, very low cost. Now, with that, there are some trade offs as always. And so we've gone to 3D printing our molds, which is decently accessible these days. And then with the materials, you can make this out of silicone or using Jello. and Knox gelatin to make it kind of a stiffer
Oh, interesting.
Jello
Yeah.
jiggler.
No,
um,
that's actually cool. It's like a chemistry class as well.
Yeah, yeah. So the students at the Haverford School where I was teaching, actually, they weren't happy with using commercially available gummy bears. They wanted to see if they could come up with their own formulation. So they started to look at the ingredients on the packet of gummy bears to see, okay, what's in here and what's contributing to the properties, and trying to make their own concoction. So it could be, it could fit really well in a chemistry class in that sense.
Hmm. I was just thinking, like, are there other opportunities for collaboration amongst the other teachers in a school? Like, I was just thinking right away, also because there are actuators involved that you kind of embed in there. Is there a need for programming? Is there a need for math? Like, what other opportunities for collaboration are there for a
Oh, yeah,
curriculum like this?
absolutely. So, we had students kind of showing off what they had done, and they were talking to their anatomy teacher who said, "Oh, yeah, this would be really great. We should talk about this in my class." Definitely, once you make the actuator, right, you need some way to power it. So, you could build a circuit and attach a motor or a pump to get this thing to move automatically. You could, yeah, create code to automate that process. Use sensors. Then you can build on the complexity. Certainly, once you get started, our focus was kind of this first introduction and reducing the barrier to entry as much as possible to get students excited. And maybe those students who initially would say, "Oh, circuits aren't for me," or an Arduino, and are somewhat intimidated, potentially once they build some actuators and they get thinking about how they could be used, then they have kind of a keen interest in building the device that's going to make it work.
Hmm. Hmm.
So trying to get them hooked and excited so that they feel comfortable to invest the time in learning how to use an Arduino to program the device.
Yeah, that's interesting that you're looking for that hook. That one of the key metrics of your success, it sounds like, is just how interested the students were after going through this. And you have some interesting quotes in the article that I should mention again, called Revolutionizing Robotics. People can find it. But one of the things that I thought was also interesting, I think there was a mention of like students posting on TikTok what
Yes,
they've
yes.
created. That's not even something I would think about, but like they're that enthusiastic that they want to share it with their family and people on the internet. Can you tell me a little bit about that?
Yeah, so we specifically asked the students. We gave them the projects that they had made, and then afterwards we interviewed them to ask them about what it was like to take it home and what did they talk about, and who did they show. And we had students showing their baseball team, and a lot of students talking about taking it home and showing their family, and these feelings of pride and getting to teach their family something new that maybe they hadn't seen before.
Hmm.
And then we had one student come to us who actually showed us a TikTok first of someone who was making a dress that had butterflies on it that could move. I think they were using like dielectric elastomers, or maybe it was no. I think they were using shape memory alloys,
Cool, cool.
and nitinol wire to
Yeah.
have butterflies on the dress that were moving. And so it was awesome. So they came to us and said, like, "Is this soft robotics? Like, this looks like what we're doing." And you were like, "Oh
Yeah.
yeah, that's amazing." And then some students were posting it, which is the next level, that they're that proud and think it's that cool that they want to show their friends and their peer group different aspects of it. So yeah, it got us thinking a lot about the role of social media
Yeah.
and how students think about it, and maybe other ways that we could reach students in this effort.
Yeah, for sure. And it reminds me of something else, which is kind of an aside. I saw that you were involved in a engineering in fashion course
Yes.
at Harvard or something. And it
Yeah.
because you're talking about, I guess, the nightingale butterflies, and it just makes me think that some fields like fashion are all over social media and TikTok. And I wonder if y'all, I don't know what your opinion is on bringing engineering to these online spaces or physical spaces that young people gather in. Are we doing a good enough job to, to be online, or do you feel like that's something that's important or not?
Yeah, I mean, TikTok is a super interesting platform. It reaches, so many young people. I think, I will say not everything about social media is positive.
Oh
So,
yeah, that's a
we
whole other
definitely,
episode. Yeah,
yeah, we're definitely cautious about,
sure.
is that the right approach when
Yeah.
we think about it? But for sure, I mean, if you can make engineering look cool and exciting, you're going to have younger and younger people thinking about it. Mark Rober, I think, does a really neat job, in
Hmm.
his YouTube presence, and maybe he has a TikTok presence too. But making engineering projects, super exciting. And I think that's important for, kids to start thinking about that as a career. Like, oh, I want to do that when I grow up. So yeah, definitely. I think I love the intersection of art and engineering and fashion. And I think that that's, just super cool. And being able to be involved in those types of projects is what kept me interested in engineering.
Hmm.
Um, so yeah, I think it can definitely increase, the diversity of the people who are interested in the field if you give them an application that they're passionate about.
I want to explore a little more about something you said. I mean, you suggested Mark Rober, who I'm aware of. That's a cool. He's a cool content creator as well in STEM. Are there other people you think, educators or engineers, just people in general? Are there other people or resources you think educators should know about if they want to share engineering and bioengineering or soft robotics to other people?
Yeah. Ooh, that's a great question.
And they don't have to be celebrities. I
Yeah,
consider
yeah,
Mark
I
Rober a
know.
mini celebrity, but like, yeah, who's your top researcher, I guess, today, besides yourself in the field?
Oh, God, that's a really good question. Okay, let me think for a second on
Yeah,
this.
sure. I wasn't planning on this. It just
Yeah,
came
yeah.
up.
But I mean, I definitely, the question gets to a really good point of, students want to see themselves in the examples. And so you asked about, making the curriculum, tailoring it to, your student population that you're teaching. We did go through our curriculum and make sure that the examples of who is an engineer and who's doing this work was representative of the population of students that we were going to be working with. So making sure that it was racially and ethnically diverse, gender diversity in the examples, so it wasn't just all kind of the same looking people who've been contributing to this field, to give students examples that they can see. So definitely, I'm gonna have to think about some names, but
That's fine. I mean,
yeah, I definitely look for women, right? Strong, high achieving women, when I'm thinking about where's my career gonna go, even from here, And so I
mhm.
think students wanna see that same thing. They wanna see someone, just ahead of them that's doing something, really cool that's, seems even just a little bit achievable, then they might be more willing to go for it.
You bring up a good point that it could be for adults as well. So I like that you reminded me of that.
Yeah, when I'm trying to show students something or get them excited, I go to YouTube. I'm not super into TikTok, so I'm not that
Mhm.
cool, but I go to YouTube and I just search up different ideas and try to see who's got a video or maybe a talk and something that's, the appropriate length and digestible and interesting. And so I think a lot of, academics have done a good job of understanding, like, you have to get the community engaged, to kind of increase chances of translating your work and getting people excited about it.
If people want to find out more about this curriculum or even the work that you're doing, I mean, clearly they can read that article in the Science Teacher, Revolutionizing Robotics. It came out recently. And they can also check out, you said, the Soft Robotics Toolkit, softroboticstoolkit.com for more information. Is that right?
Yeah. Yep,
Okay.
that's it.
Are those the best resources, or do you suggest any other ways for educators to learn more?
Yeah, so we're definitely putting a lot of effort into the Soft Robotics Toolkit to make it approachable. There are other activities that are posted on that website that are good for K-12 teachers that come with instructions and bill of materials, to kind of help support that work. I try to keep my website, hollygolecki.com, somewhat updated with what I'm up to, and I'm always happy to answer questions. What I really try to do, whenever I'm teaching students, is build in like a community engagement piece where they're reaching out to people who are doing interesting work in the area that they're working in, just to ask a question or request a quick meeting, to learn more. And so I always encourage students to do that, and you'd be amazed the opportunities that turn up when they do that. And so, I'm always happy to answer questions, and people are free to email me as well.
Fantastic. And they can Google you at UIUC's website, I'm sure. Are you
Yep.
on, you're not on TikTok, it sounds like, but
No,
should they reach out to
I
you
am
on
on Twitter though.
Twitter? Okay.
H. Galecki on Twitter.
Okay. You don't call it
Uh,
X now, it sounds like.
oh, X, yeah.
I don't know. I don't call it X either, but Twitter's a whole other conversation as well.
Yeah, yeah, for sure.
But no, that's great. There's still educators for sure all over Twitter/X. And yeah, please reach out to Dr. Holly Golecki. So, Holly, really appreciate your time. I think we're at the end of our time here.
Yeah,
Are there any
yeah,
other
of course.
plugs that you have?
I guess I'd say one more thing.
Yeah.
You brought up the idea of interdisciplinarity and teachers working together. One of the most exciting projects we had was when I was a teacher. We were going to Louisville, Kentucky, to Vex Worlds, and we had a colleague of mine who teaches ceramics was chaperoning with me. And he started to ask questions. We were working on soft robotics, kind of thinking about that, even on this Vex trip. And he started to ask, like, maybe could you make me a glove that, I could help to use as a training tool for students who are new to ceramics. He's like, I have all this knowledge and this muscle memory built up over years and years of practice. And it's really hard to verbally communicate that to students or to communicate to a lot of students all at once. And so the students on the project actually ended up building him a glove, a sensor glove for him, and then an actuator glove for the students. So he would apply pressure to a piece of pottery that was spinning on the potter's wheel, and the student could actually feel the pressure that he was applying on their own finger to help guide them. And so we did end up publishing that work along with some other development on the actuator side, but it was a really awesome, opportunity that came out of just kind of chatting with people.
Yeah.
And I think, there's just so much area to explore there.
That's fascinating. Yeah, I'll ask you if you have a link or something to please share that, and I'll
Yeah.
try to include that in the notes. And just in case I'm forgetting, was there a competition actually coming up from the Soft Robotics Toolkit in the fall?
Yes. So the exact competition that got me kind of started in this field is hosted by the Soft Robotics Toolkit. It's open to anyone, so it can be hobbyists at home, academic researchers, high school students, and there are different categories. Is open until October 31st, and so again, it's really open-ended. If you have any ideas, designs, prototypes, concepts based in the field of soft robotics, we would love to see them. And it's a nice community event.
Thank you, Holly. And I wish you luck, of course. Wish your students good luck in all of this cool research. And I will be very interested to find out more about what your team does.
Yeah, thanks so much for having me today and for the discussion.
That was Dr. Holly Golecki, professor in the bioengineering department of the University of Illinois at Urbana-Champaign. Check the show notes for links to what we talked about, like the Soft Robotics Toolkit at softroboticstoolkit.com. The K-12 Engineering Education Podcast is produced by my indie studio, Pios Labs in Austin, Texas. Pios Labs fosters growth in engineering and education through edtech, digital media, games, and professional development. Follow Pios Labs everywhere to stay updated. That's PIOSLABS. So, listener, once again, thank you. Thanks for joining, for sharing the show with your work and your friends. Thanks for donating a few dollars to the show on Patreon each month at patreon.com/PiosLabs. In 2023, it's great to still be talking engineering education. Until next time, take care.